What's going on, everybody? Got another video here for you. Got an equation here to solve. It's a trig equation. It looks complicated, but let's hope it's not. Alright, so first thing I notice here, we've got the largest degree is a cube. So need to try to factor it, and it looks like we can factor it. We got four terms here, so we can split it down the middle, do some factor by grouping. So out of this first part here, let's factor out a 3 times tangent squared x, and then in here that would leave us with tangent x minus 1. And then here, notice we have a negative tangent plus 1. I need those signs to swap, so I'm going to factor out a negative 1, so that'll leave me with a positive tangent minus 1 equals 0. And so now we have this common factor of tangent x minus 1, so I'm going to factor that out. So I've got tangent x minus 1 times 3 tangent squared x minus 1 equals 0. So we've got it factored. So now I'm just going to set each factor equal to 0. So I've got tangent x minus 1 equals 0, or 3 tangent squared x minus 1 equals 0. And so here this is going to give me tangent x equals 1. And then if I solve this one, I get 3 tangent squared x equals 1. Divide both sides by 3. I get tangent squared x equals 1 over 3. And then we'll square root both sides. So tangent x is equal to plus or minus 1 over square root of 3. And so I'm going to go ahead and rationalize that denominator. So that's going to give me tangent x is equal to negative square root of 3 over 3, or tangent x is equal to square root of 3 over 3. All right, so now let's solve. And by the way, we're going to solve this between 0 and 2 pi. Not 2x, 2 pi. All right, find all the solutions between 0 and 2 pi. All right, so here I've got x equals a positive 1, so I get x is equal to pi over 4. The inverse tangent of 1 is pi over 4. But we know tangent is also positive in the third quadrant, so we need to get that solution. So our reference angle is pi over 4. Okay, remember that. You got to get your reference angle. And so our solution in the third quadrant would be x equals pi plus pi over 4, which is 5 pi over 4. And so there's that solution, 5 pi over 4. So there's the solution for tangent x equal 1. Now let's look at this one. Tangent x equals negative square root of 3 over 3. So this tells me that my solution is in the second and fourth quadrant, because that's where tangent is negative. So first I need to find my reference angle. So I'm going to find my reference angle. Remember, whenever you take the sine, cosine, or tangent of a reference angle, it's always going to give you a positive answer. And so now I get x prime is equal to, well, what's the inverse tan of square root of 3 over 3? Well, that would be pi over 6. So that's my reference angle. So now let's just come over here, and I'm looking for when tangent is negative. Well, it's negative in the second quadrant. There's my reference angle, pi over 6, and that's x. So x is pi minus pi over 6, which is 5 pi over 6. And then for this one, we've got our solution in the fourth quadrant. There's my reference angle, pi over 6. So I need that angle. And so x is equal to 2 pi minus pi over 6, which that's going to be 11 pi over 6. So I get x equals 5 pi over 6 and x equals 11 pi over 6. And there's the solution for that. So now we got to work on this one. So tangent x is equal to a positive number. So that tells me my solution's in the first and third quadrant. So the inverse tangent of square root of 3 over 3 is pi over 6. And then I need my solution in the third quadrant. Well, there's pi over 6, my reference angle. We'll call that x. X is equal to pi plus pi over 6, which is 7 pi over 6. So 7 pi over 6. And there's your answer right there. So, you know, it looked like a difficult problem, but remember the thing about this, when you have something like this, what you want to do is you need to get to where you break it up so that you have just a single trig function equals a number. See, like this right here. Okay, and then once again, we got to that here, and we got to that here, and then you just solve each one of them individually. All right, so I hope you enjoyed that video. I hope it helped. Check out my other videos. Give me a like, share, subscribe, comment, and I will see y'all in the next one. Later.